Now that we have talked about logarithms and figured out what is a logarithm, we're going to look at logarithms and their graphs. As we know, we can find out a lot of information when we look at a graph of any type of function. So with that being said, let's say for instance that we have log of base 6 x minus 4. So we're going to be looking at this in terms of, okay, what happened to this graph? Did it move left? Did it move right? Did it move up? Did it move down? You know, how is the graph a little bit different? What's the domain? What's the range? Intercepts, all of that good information. So when we're looking at this, we're going to go to Desmos like normal. In order to change the function or to change that subscript, our base of our log, if you look there, there's two options for your logarithm. There is an option with a base A. So in our case, we had a base of 6. Because I need that parent function to determine what actually changed, I'm going to list it as twice. And then my other one is going to be the minus 4 graph. So we can compare and contrast what has happened between our two functions. So when we look at this, log of base 6 of x originally, it crosses here at the point 1 comma 0. As you can tell on the green graph here, this is now at 5 comma 0. Well, that's a transition that we can see here of plus 4. That's interesting because I have a minus 4 there, right? So this is following our transformations that we've had before. So if you're going back to your actual notes here, so our graph moved to the right 4. And that's pretty basic to look at and figure out, okay, why that is. So if you notice here, the difference is just that transition of 4. Our domain did change a little bit because of that 4. So our domain for our green graph here, I would write this in your notes as well. If you're drawing a sketch of this, I would just draw a rough sketch in your notebook. The domain, though, for our green graph here is from 4 to infinity. And looking at our range goes from negative infinity to infinity. Okay. Intercept, we don't actually have an intercept because it doesn't have a y-intercept. It does have an x-intercept there at 5 comma 0, and our asymptote line is that 4. So that's part of our transformations and kind of looking at stuff in general. There will be times when we will need to find the equation of the inverse of the function, and it's just rewriting it. I know that's fancy terminology. Ooh, sorry. All this is just fancy terminology for rewrite this in exponential form, or going from exponential form into logarithmic form. So if we were to have 2 to the power of, let's go, x minus 3. So like any inverse, our first thing is to switch the x and the y. If we're going to solve this kind of algebraically, so we have 2y minus 3, 2 to the power of y minus 3 equals x. So now I'm going to, change this so I'm solving for y. So I'm going to bring out that exponent out front, and this is now going to be log of base 2 of x. Okay, so now my last step is to get y by itself, so I'm going to move that 3 over. Y equals log of base 2 of x plus 3. Now, here's the thing to note. Notice I put parentheses around that x because I don't want you to think of it as log of base 2 x plus 3 as one whole thing. That log is only pertaining to the x. It's not pertaining to the x plus 3. If you would like to write down the steps off to the side, that's what we're doing there. Sometimes we'll go the reverse way. We'll go from log form first into exponential form. Let's say that we have log of base 6, x minus 2 in parentheses, plus 4 equals y. So again, first step of any inverse is you flip the x and the y. So we have log of base 6, y minus 2 plus 4 equals x. So we're going to solve for y. When we're doing this, that log is with the y minus 2. It's not with that 4. So we're actually going to move that 4 over first. So we have log of base 6, y minus 2 equals x minus 4. Now that I have that log separated by itself, I'm going to go ahead and switch this into exponential form using that e trick, right? So this is 6 to the power of x minus 4 equals y minus 2. Well, I've got one last step, and that's to solve for y. So this is now 6 to the power of x minus 4 in parentheses plus 2. And that equals my y. So again, we're just looking at the graphs of our different log functions, which you can use Desmos and figure out, okay, domain and range based off of that, and figuring out any asymptotes or intercepts or whatever it is that we're looking for in that situation. We've talked about the transformations, which you, again, look at the parent function and compare and contrast. And then finding the inverse of our functions. Same inverse formula that we've been working with before, just a little bit more intense because we're using log functions now. So with that, that's our log functions and their graphs and how to find those inverses.